Hi, my name's Craig Foley. I'm the Chief Sustainability Officer for Lear Realty Partners. We're the largest independent brokerage in New England with over 700 agents now and 40 offices. I'm here with David Bearg tonight. I'm very excited to have him here. He is a client, a homeowner, but also an expert on indoor air quality. So this is a 1993 book he wrote, which I can say is part of the green building world. Indoor air quality really has only come to our focus in any kind of intense level in the last 10 years. You beat that by a long time, David. I can say for sure. And on top of that, you were part of Governor Dukakis's commission on indoor air pollution in the late 80s. So I'm fascinated and want to hear all about your background. I've studied a little bit. I know your dad was in the HVAC industry, but can you kind of give us the big picture of, why you're so interested in this stuff as
Well,
well?
you mentioned my father. I mean, he was a professional engineer, and before computers, he would do the heat load calculations for office buildings in Manhattan. So, at an early age, I was exposed to the HVAC world in junior high school when we covered our textbooks. I covered them in blueprints.
Yeah.
So, that was kind of part and parcel of who I was. And then I guess the most significant thing happened when I was a young teenager. I went off to a camp called Bucks Rock, which basically suggested that if you immerse a kid in a creative environment, let him decide what he wants to do, and you'll find it very rewarding. And so early on, I got used to having a project, something I could create. And I guess also, coming out of college in the 70s, um, and having a master's in environmental health, I was to the core an environmentalist. And part of that was sustainability. Try and live as simply as possible. And in fact, try and live the way people will need to live in the future so that I can be ahead of my time. And that's sort of been consistent throughout, is that I've sort of been ahead of my time in making priorities. And so when I had the opportunity to purchase in Concord, Mass in 1975, I managed to buy a 700 square foot summer cottage, which was a great starting point. And then, having grown up in New York, I was used to a longer growing season. So one of my first projects, um, well, I had met a friend, Mark Ward, who was in the business of recycling greenhouse materials. So I got together with him and Jerry Lax, and so we built a heat storing greenhouse.
I've been involved in the green building space, listing high performance builders that, builders are building to LEED certification, the passive house certification now in Massachusetts. It looks like passive house is going to be next part of the next building code. So that's going to be a significant improvement, right? In which, again, you were doing this in 86 and 89 when you were building the extensions on this building thicker walls for a super insulated building. You know, I mean, I've been at this for well over a decade, and you you were so far ahead of your time, David, in terms of looking at this and thinking about this, right?
It's kind of the combination of being in college in the late, you know, 60s and Earth Day, and then getting a master's. Well, my bachelor's in chemical engineering and then my master's in environmental health. It sort of sustainability became um, part and parcel of that, and so I wanted to live the way people would have to live in the future as energy got more expensive and supply chain issues were magnified, and so that's always given me the flexibility, because I was spending less money to keep myself comfortable, and so I didn't have to work as hard to earn the money I needed, which gave me more time to work on my projects. And because I was self-employed, when there was work, I was available quickly to, we've got a problem, we want it to go away yesterday. I would be available, but then when I wasn't solving problems, I was working on the house.
Right. You talked about contamination in a building. Um, I'd like to go back to that just for a second. What is, so first of all, the EPA currently says the indoor air quality in the buildings we live and work in is at minimum 2 times to 5 times worse than outdoor air pollution, and in extreme circumstances, 100 times worse. What are the contaminants in a residential home or a commercial building that I just don't think there's a lot of awareness out there for
Oh yeah, I
homeowners.
mean everything from, let's say you bring your clothes to be dry clean. There's a certain amount of off gassing, so you don't want to bring clothes from the dry cleaner directly into your closet where it can off gas. You want to let it air out outside, but electric wall ovens with a self cleaning cycle, you turn that on and it will eventually clean the inside of the oven, but um, probably it will also release PAHs, polycyclic aromatic hydrocarbons, which you don't want to breathe. So in my house,
They sound bad. I don't want to breathe them, I can
right. So in
guarantee
my
you.
house, I have a electric wall oven, and there's an exhaust grill right above, such that I've identified a potential source which I didn't want to eliminate. I mean, to you don't want to put carpeting on an uninsulated basement slab, but where there was a high volume copier, I put an exhaust right there. I have a large industrial hood over my cooktop. Those were for contaminants that I couldn't eliminate, so I would capture and remove any air contaminants at those spaces. Um,
And today we have even, I mean, last builder show I was at, one of the hottest tables was the real-time monitoring of indoor air quality. So monitoring, being able to monitor in real time on your iPad volatile organic compounds, not only humidity and temperature, well, temperature obviously we've had in our homes real time for a while, but humidity levels as well, which are really important to this. I mean,
oh, clearly, if you want to manage something, you need to measure that,
mhm.
because it's a lot easier to manage something if you're measuring it. And so part of my time I spent in buildings monitoring carbon dioxide and dew point together. And you can learn a tremendous amount of information about whether or not the building is functioning as intended. But it was a new idea, and I once again was in the market too soon. And it was an excellent system, but it never really captured a foothold. But for those buildings that we would monitor, you could assess the adequacy of ventilation. You could assess the effectiveness of the overnight purge. I mean, let's say the HVAC system shut down at 5 and people persisted till 9. By the next morning, there was still bioeffluents, CO2, left over from the prior occupancy. You could also identify areas that were overventilated and potentially um, could be used to get more energy and save some money. Um, you could evaluate if you had a difference between indoors absolute humidity and outdoors, typically dew point temperature. You could see where there was infiltration, where air from outdoors was being sucked in and unconditioned outdoor air was being sucked in. Also, it was kind of an early warning system if you had elevated moisture, which is a precursor to mold growth.
Right.
So no, I'm a big believer that we could do a better job in monitoring and I use the term AI, either artificial intelligence or just automated auto interpretation. By looking at those two parameters, you could predict and generate the logic to say, well, if this condition exists, this is what's going on in your building, you should address it.
Mhm.
So I still have some ideas about how we could do better in the
Yeah.
future.
Well, one of the places you mentioned CO2, right? When mom and dad go to bed at night and they're taking in oxygen and giving off CO2, that's raising the levels with the closed door in the bedroom. And again, Chan School of Public Health doing some excellent work on how that's impacting sleep quality for parents as well. So these are real-time issues for homeowners and business owners.
Oh yeah, there's a lot of misbeliefs out there that many builders say, oh, you can never build a building tight enough for it to be a problem, but then you're going to depend on the indoor outdoor differential to drive it. So at times you'll get too little ventilation, and when it's cold outside you'll get too much ventilation. So you really want a very tight building envelope to give you the ability to control, and then um, have a mechanical ventilation system that can provide as much ventilation as you want and need. You
I
know,
hear this all the time from realtors, by the way. So, I teach the green designation for National Association of Realtors, And we're talking about the latest advances in building science and super insulated buildings and well-sealed buildings and, what a blower door test is and what passive house requirements are, which is for a very, very tight building. And inevitably, I'll get a comment from a realtor that believes buildings have to breathe, right? And, buildings do have to breathe, but it's kind of like, we have our lungs, we have a breathing system. We don't take a knife and, poke holes in our lungs to breathe, which is essentially what we're doing with homes that are, breathing homes.
Right. We have an outdoor air intake, which is prominent in our face.
Yeah.
That's how important it is. But yet, the outdoor air intake in buildings is sometimes below grade, behind, or I've seen all sorts of wrong places for the outdoor air intake. There was a bank with a drive-up window, and if more than 3 cars were waiting to deposit checks, the exhaust from the automobile got sucked into the building.
Yeah. Yeah.
And there was another building where there was the architects decided that the space above a loading dock would be an excellent place to put a mechanical room. And all mechanical rooms suck air from where they are.
Yeah.
And so when a diesel truck would back up to the loading dock, that air would get sucked into the mechanical system and delivered to the spaces. So typically not been the appreciation that's been needed.
Yeah. So essentially, there's no such thing as a too tight building, but there is such a thing as a too tight building without proper ventilation.
Definitely.
Yeah.
Definitely.
Proper ventilation being critical. And, as you know much better than I do, there are natural ways to ventilate a building, a home, and there are mechanical ways. Can you kind of give us a brief history of what ventilation and for residential and commercial buildings, what that story has been like over time?
Well, I'm reminded a little bit of an anecdote because there are termite mounds, and they modify their natural ventilation just by the way they're designed and built. And so what you want is, once again, the geometry of air movement. You want the air to be able to come in low and leave high, where it picks up heat, and just the buoyancy is the driving force. And you can supplement that with some kind of solar PV or solar hot water to add to that buoyancy and have a stronger driving force. One of the experiments I did here is I put up a PV panel, connected it to a fan, so when I'm out in that particular shed, it's being ventilated by the power of the sun. So just, this has been my playhouse, a chance to try things, and sometimes they work and sometimes they don't. And but it's, as my sons are often say, well, Dad needs a project, and so.
Well, we'll go in and take a look at some of the specific places where you've experimented, and you can take us through what that actually looks like.
Sure.
Yeah. David, when I met you initially, I had done a little bit of research. You gave me some information about your background, and I knew you were an energy efficiency geek. So I expected when I came in here, there was going to be something special, and I saw it immediately. I don't think the average home buyer would necessarily pick this up, but you can see that there's a very thick wall here. And I asked you immediately, is this a double stud wall? And you said it was, in fact. And we both know the reason for that. It wasn't until very recently, the last code cycle, that we went from requirements from 2x4 construction to 2x6 construction. And the reason being, we want the extra 2 inches of insulation in there, right? You were, again, way ahead of its time. This is a 10-inch thick wall so that you could maximize the R value and keep the heat inside, keep the place more comfortable to live in and with lower operating costs.
Well, actually, this is a faux foot because it's 10 and a half inches of fiberglass.
Yeah.
And there's the outer one, the fiberglass is vertical. Then the middle one, which provides a thermal break all the way across the wall,
Right.
is horizontal, and then there's a vertical inside. And it also has a vapor barrier and plywood 1/3 of the way in, such that it gives you a wiring chase inboard of the vapor barrier, so you don't have to worry about penetrations and all the leakage that goes with that.
You're venting in between the two sets of windows
Exactly,
here?
to the outside.
That's fascinating.
But
yeah.
that's just cold air settling.
Yeah.
And so I'm capturing, it's like a hot air balloon that, it gets the warm air. So there's no impact on the thermal effectiveness. And then there's also shades that come down to reduce the heat loss.
And so this window system has been in place, if I've got the math right, for about 37 years and working effectively, no broken seal. I mean, there wouldn't be any broken seal because it's being ventilated.
Right.
I think that's fascinating. So, David, when we were touring the house initially, I saw these panels over the windows and I was wondering what they are. Can you explain this to us?
Oh, sure. I mean, if you're going to have an energy efficient home, one of the biggest potential problems is the heat loss out of windows. So instead of just an R2, I felt by having movable insulated panels, I can change that R2 to an R4.5 by having these movable insulated panels. They just can make the room dark in the middle of the day. And it's just another example is kind of just to close the panel. We've got a thickness of insulation, and voila, you have reduced your heat loss. And if you want the view becomes available. In the continuing effort to reduce heat loss at the windows, I started incorporating that into this bathroom detail where I knew I wanted to have a mirror. So I hid the movable insulated panel to behind so it disappears, as well as just having a movable panel. It just closes that way. One facet of this greenhouse, and it's part of extending the growing season, is it has 11 tons of rocks that can actively store heat during the early part of the winter, and thereby make the interior frost-free earlier in the season than it would be otherwise, without using supplemental fossil fuel or electric heat.
So the rock is capturing kind of the thermal energy as a kind of storage system.
Exactly, thermal flywheel.
Yeah.
Where there's a fan and a thermostat, and when the set point is exceeded, the fan comes on, it pulls heat off the peak and down through the rocks and then back into the space.
And part of what I think is one of the fascinating stories at this house that both you and Katie have been deeply involved with is, you mentioned thinking forward when we were sitting down together on the porch, right? That thinking forward not only had to do with energy efficiency and ventilation, but also food production.
Exactly.
So when this was working at its peak level and the gardens outside, tell us about what that would be like for a homeowner coming in.
Well, I never really got up to the full potential, because the full potential really would involve a community-based food production where you can just get a lot of plants started earlier in the season and then share those plants with a larger community. And quite a significant amount of food, I believe, could be created without having to transport food 1,200 miles. And
right, the embodied energy of food production is huge. I mean,
exactly.
Just the transportation. I mean,
and so they're predicting 23% increase of food costs in 1 year because of different supply chain issues and global disruptions. The food that normally comes out of the Ukraine is not happening,
right,
and that's going to have consequences on a global.
Serious consequences.
So in terms of sustainability, we need to think about, as you said, not only a healthy indoor environment, an energy efficient indoor environment, but the ability to produce one's own food, to live more simply on this planet. And I used to have a shirt, I try and live simply so that others can simply live.
Talking about food production, David, all of the buyers are really impressed with how the blueberry bushes have really come in. I mean, this is a great season for blueberries.
Well, in one of the books that I haven't had a chance to write yet, but first you plant blueberries. It's like, the best time to plant a tree is 20 years ago, but then the next best time is right now. And, I really like the blueberries we have early, mid, and late season. And they're coming in beautifully. They're just coming in now at the end of June. Sometimes they're a little tart.
This 25,000 square foot lot, which is rare in Concord, but there's two additional lots, 4,000 square foot are over here and a little bit more than 5,000 across the street. That 5,000 square foot lot you have set up as a terrific garden. When did you start that process, and what have you produced out there?
Well, the garden used to be on this side of the street, but then as the trees grew up around it, I ended up being able to acquire that 5,000 square foot lot, and so that had a better solar access. So that just evolved over time.
Yeah,
it's a challenge because the soil is so sandy that it's hard to maintain the needed level of organic material. But fortunately, because I own both sides of a private way, I was able to run electricity and water underneath, so I have an irrigation system.
Yes,
that gives me a chance, and I've got some tomatoes that are just coming in.
Yeah, and a couple of compost bins over there. I'm sure you're using as part of the organic matter.
That's part and parcel of the whole process.
Yeah. Thank you so much for this interview. I can't tell you how much I've appreciated our friendship, since we've been working together, and been really inspired to read your work. I had no idea that there was an indoor air pollution task force that Governor Dukakis, put together in the late 80s. And I'm pretty informed about this stuff, so I was absolutely fascinated when we worked. Thank you so much for joining us here. I can't tell you how much I appreciate it.
Oh, it's been my pleasure, clearly. Thank you.
Yep.